Have you ever stopped to wonder what's really going on when milk goes sour or when a shiny new bike gets all rusty? Well, those are chemical reactions, these amazing little transformations happening all around us, all the time. Today, we're going to be chemical detectives. We're on the hunt for the 4 big clues that tell us, hey, a reaction is happening here. So let's get our investigation started. We're the faculty team from Roy's Academy, and in this explainer, we're diving right into chemical reactions and their indicators. This is a key topic from the CBSE Class 10 science curriculum. Now, if you find this explainer helpful and you're looking for more, you can always connect with us at Roy's Academy. Our number is 89108903111. Let me just say that again. It's 89108903111. And we have another number, which is 89106000503. One more time, that's 89106000503. All right, let's get back to the case. So let's start with something we've probably all experienced and not enjoyed. You leave a glass of milk out on a warm day and, yuck, it goes from being perfectly fine to this sour, clumpy mess. That change in smell, taste, and texture, that's our very first clue that a brand new substance has been created. Or how about this one? You've got a shiny, strong iron pan, but if you leave it out where it's damp, it starts to get that reddish-brown, flaky stuff on it. That's rust. The original iron has completely reacted with the air and water to become something totally new and brittle.
And it's not just happening out there in the world, it's happening inside you right now. The food you eat gets broken down into simpler bits to give you energy. That whole process is just a super complex series of chemical reactions that, well, we literally couldn't live without.
So in every one of these situations, the original stuff has basically changed its identity. But, as scientists, we can't just rely on a gut feeling. We need actual proof. So the big question is, how do we know for sure that a chemical reaction has happened? To figure that out, we're heading into the lab to gather some solid evidence.
Okay, our first piece of evidence is going to come from a pretty simple experiment involving a strip of magnesium ribbon. Let's see what happens when we introduce it to a little bit of heat.
So the plan is pretty straightforward. We're going to take a clean piece of magnesium, hold it carefully, and burn it. Then we'll collect whatever is left over. The most important part here is to keep your eyes peeled and observe everything that changes. So what do you think is going to happen when you burn a piece of metal? Come on, make a prediction. What kind of clues should we be looking for?
And whoa, check that out. The ribbon doesn't just catch fire, it erupts in this incredibly bright, dazzling white flame. And look what's left. That solid, bendy piece of metal has completely transformed into a fine white powder. That's magnesium oxide. So right away, we've got our first major clues, a huge change in color and a change in its state.
All right, clue number 1 is in the books. Let's move on to our second experiment to see what else we can find. This time, we're ditching the flame and we're just going to mix 2 liquids together. For this one, we're taking 2 simple, clear liquids. They look just like water. One is a lead nitrate solution and the other is a potassium iodide solution. We're just going to pour one into the other and see what happens. Okay, get ready and watch this. The very instant those 2 clear liquids touch, a vibrant, bright yellow solid just appears out of nowhere. It's incredible. We started with 2 see-through liquids, and now we have this bright yellow powder swirling around. That is a massive clue, a change in color and another change in state, from liquid to solid. Okay, we've got some great evidence so far. For the last piece of our puzzle, we're going to see what happens when we introduce a metal to a common acid. This experiment is going to give us our final crucial clues. So for our final test, we'll take a few small pieces of zinc metal and drop them into a flask. Then, nice and carefully, we'll pour in some dilute acid and watch very, very closely. All right, what's your prediction for this one? We're adding a liquid to a solid metal. What kind of signs do you think we might see this time around? And look at that. We get 2 clues for the price of 1. First, do you see all those bubbles fizzing up from the zinc? That's a huge sign that a gas is being created and released. And second, if you were to touch the flask, you'd feel it's actually getting warmer. That heat is energy being released by the reaction. So we've got another clue, a change in temperature.
All right, detectives, our investigation is officially complete. We've gathered clues from burning metal, mixing liquids, and dropping acid on zinc. Now it's finally time to put all the pieces together and solve this mystery. And here it is, the solution to our big mystery. We can be pretty confident that a chemical reaction has taken place if we spot one or more of these four key signs: a change in state, a change in color, the evolution of a gas, or a change in temperature. These are our four main indicators. Let's just trace our evidence back for a second. We saw a change in state when that magnesium ribbon turned into powder. We saw a big change in color with both the magnesium and when we mix those two liquids. The fizzing zinc gave us our gas, and that very same reaction got warmer, showing us a change in temperature. See? Each experiment gave us a vital clue. So there you have it. These four signs: change in state, color, gas, and temperature. They're your official chemical detective's toolkit. Now you can look at the world around you, from a campfire to baking a cake, and know exactly what signs to look for to spot the chemical reactions in action. But that leaves us with one final, pretty interesting question to chew on. We've seen reactions that show one or two signs at a time, but do you think it's possible for a single chemical reaction to show all four indicators at the exact same time? What would something like that even look like? This explainer on the indicators of chemical reactions was an initiative from the Roy's Academy faculty team. We hope you enjoyed our little investigation into this part of the CBSE curriculum. For more video explainers just like this one, please feel free to connect with Roy's Academy. You can reach us at 891-089-0311. Again, that number is 891-089-0311. Our other number is 8910-60-0503. Let me repeat that one more time for you. 891-060-0503. Thanks so much for learning with us today.